Number 6 says, given mass amounts for 2 or more compounds, be able to determine if they have the same formula or not. So this is where you put it all together. You do the calculating. You decide, is it the law of definite proportions or the law of multiple proportions? So if this was the problem I gave you, if I said a scientist has 3 compounds of tin and chlorine. Compound 1 contains 11.26 grams of tin, 6.74 grams of chlorine. Compound 2 has 5 grams and 5.96. Compound 3 has 28.15 and 16.85. What conclusions can you draw about these 3 compounds? Well, you have to do some calculating. Although when you look at it, which compound do you know right away looks different than the others? The second one, because what's different about the second compound? It has smaller numbers, but there's another big difference there. The numbers are close to each other, and also what's true about tin compared to the chlorine with 2? Tin's less than the chlorine, right? But on 1 and 3, tin's more than the chlorine. So 2 is definitely going to be different. Okay, so if you wanted to tell me compound 2 can't be the same as 1 or 3 because it's less than 50% tin, that'd be fine. You wouldn't even have to do any calculating as long as you could explain the reasoning to me. But compound 1 and 3, I can't tell. They're both a little ways apart. Are they the same thing? I'd have to do some numbers. So you have your choice. You can do the mass percent or you can do the mass ratio. So let me just type that in for the folks at home. So you need to calculate mass ratio or mass percent. If I get my choice, I'm always doing mass ratio because it's easier. I don't have to add up the total and I don't have to multiply by 100. The only thing tricky about mass ratio is you have to, if you put tin on top for the first one, you have to put tin on top for all of them. You have to compare it the same way. So I'm going to, for compound 1, I'm going to take 11.26 grams of tin and divide by 6.74 grams. And someone tell me what you get there. Like 1.8 maybe? Yeah, divided by 6.74. 1.67. And you can just leave it 1.67 or you can put to 1. I don't care which way. So if the to 1 is confusing you, just don't put it on. That's the mass ratio, 1.67 to 1, and that's grams of tin to grams of chlorine. So then number 2, I'm going to do the same thing. I'm going to take my tin, which is 5, unless you want to go ahead and explain it to me. It's probably quicker just to show me with the math. 5 grams of tin divided by 5.96. That's going to be point something. 0.84. And then number 3, I've got 28.15 divided by 16.85. And this one's also 1.67 to 1. So now you can draw 2 conclusions. It's important you draw a conclusion about what's the same, but it's also important you draw a conclusion about what's different. So the obvious conclusion is compound 1 and 3 are the same substance, since the mass ratio is the same, but compound 2 is a different substance since the mass ratio is different. And if we happen to know the formula for compound 1 and 3, we could figure out the formula for compound 2 because we can see its tin is about half as much. But again, that's something we'll be doing later in the year, not quite yet.